welcome back to the channel. So in continuation to the LeetCode Daily challenge series, we are working on today's LeetCode challenge problem. The problem statement says we have n repeated element in size to an array. So we are given an integer array nums with the following properties. Nums dot length is equals to twice the n. So it is always the size is always an even number. Nums contains n plus 1 unique elements. So more than half plus 1 are the unique elements. Exactly one element of nums is repeated n times. Okay, so there is one element which is repeated half number of times because n is half of the length. We have to return the element that is repeated n times. Okay, so let us try to understand with this example. 1 2 3 3, the total size is 4, half of 4 is 2, and we have to find the element which is repeated 2 times. So 3 and 3 here, so the answer is 3. Try to take a look at this one. 2 1 2 5 3 2, the total size is 6, half of 6 is 3, so we have to find the element whose frequency is 3. So I can see 2 is repeated 3 times, so output is 3. Let us try to understand this one more example. 5 1 5 2 5 3 5 4, it contains 2 plus 2 4 6 8 elements, and out of 8 half element size is 4, so element which is repeated 4 number of times is 5, so the answer is 5. Okay, so the problem statement looks simple if we have to find the element with half of the frequency, but there is another one hint and catch during which we can optimize this question. It mentions nums contain n plus 1 unique elements. So out of these 8 elements, half of 8 is 4. So there is one element which is exactly same. Okay, so 5 is repeated 4 number of times. So for the remaining 4, whatever the elements are there, those are all unique elements. That's the hint that they have provided. So if it contains n plus 1 unique elements, now I'm asking how many such numbers are possible whose frequency can be more than 1. The answer is 2. The answer is 1 because no element can repeat apart from the answer variable 5, because they all the other 4 elements must be unique. This is the hint. So the brute force approach, what we can do is, for the brute force approach we can simply take a look at the we can start iterating on the list nums, and while iterating we can take a copy of we can keep the frequency in a map, and whenever the frequency reaches more than twice, that is our answer, so we can simply return from that point. But when we talk about time and space complexity, the time complexity for this approach would be O of n, because we are iterating on each element, and the space complexity would also be O of n because we are using auxiliary separate map for storing the elements. Now when we want to optimize this using this hint, what can I think of? The the hint that is coming to my mind is, if all the elements, half of elements are unique, how can I distribute them amongst the other half so that these elements are furthermost placed? Can we find the elements if I make the subarray groups of, let's say, 3? Can I find the repeated elements in these subarrays? 1 2 3 1 2 3? Yes, here it is matching, so I can be able to find. Try to solve with this. 2 1 2, 2 is repeated, so 2 is the answer. Try to look at this one. again here in the 3 I found out one element which is repeated. Can I this is the answer now. But can you think of this case where this is the input? Now if this is the input, I made subarrays of 3, 9, 5, 6. All elements are unique, nothing is repeated. Now the next subarray is this 5, 6, 9. All are unique, no one is element. So did I get the answer in this? No, I did not. So 3 doesn't work. So next more than 3 is 4. Can I make subarrays of size 4 and try to figure it out? Yes, I think I can. Try to think on this approach first. I made 4. Yeah, 3 is repeated in this first subarray of size 4. 3 is the answer. Now in this subarray I found out 2 is the repeated. This is the answer. I don't need to even go further. In this subarray 5 is repeated twice. In the first subarray 5 is the answer. In this subarray, which is a corner case, is the element repeated? Yes, 9 is repeated. And what is the answer? 9 is the answer. We can simply return. Okay, so I hope the approach is clear. Now try to quickly code it out. So this is the total number of elements present. Now we need to start iterating on the nums. Whenever I am at the current position I want to check with I plus 1, I plus 2, I plus 3. So what I want to do is, if nums of I exactly equals to nums of I plus 1, if both are matching, what is my answer? Nums of I is my answer. But in order to access I plus 1, I need to ensure my array doesn't exist out of bounds. So I will update the loop condition. Now what is my next condition? If nums of I is exactly equals to nums of I plus 2, if my ith element is matching with I plus 2th element, then also my answer is nums of I. Similarly, if my ith element is equal to I plus third element, my answer is nums of I. But in order to access these two elements, I plus 2th and I plus 3th, I need to ensure my array doesn't exist out of bounds. So instead of updating here, I will add a condition here that I plus 2 is less than n. Okay, yes, I hope this will work. And the default return would be, let's say, 0. Try to run this. Yes, sample are passing. Let's try to submit this. And yes, it is successfully passed, and it takes the 0 milliseconds. It means it's the fastest. Now let's try to find the time and space. So we are iterating only once on the array, so it's O of n 1, and space, sorry, it's O of n, and in terms of space we are not using any extra space, so it's O of 1. I hope the approach and solution is clear. If you guys have any questions or doubts, please do let me know in the comments. Thank you.